project is on the gasification of sustainable biomass materials for CHP application. The context of my project is creating a sustainable source of heat and electricity. We all know the threats caused by climate change and global warming, and if we can create energy from what's currently seen as a waste material, we're solving two issues at once. My research is important because governments across the world have signed up to be carbon neutral by the year 2050. And to reach this goal, they're going to have to find sustainable sources of energy, so renewable energy, and gasification of sustainable biomass materials is one of these methods. The issues that I'm fixing are the amount of agricultural waste that are currently produced in Northern Ireland, and farmers currently need to pay for disposal of this material or spread it on land, which can lead to other environmental problems like eutrophication of waterways. There's the team here at the Ulster University, the bioenergy research team that I'm part of, and then we have an industrial partner, JMA, based in Portadown, who are designing and fabricating gasification units for installation on farms across Northern Ireland and the UK. And then we have the team at AFBI who are helping me by supplying materials to the project. So there's another PhD student there who I work very closely with. And then I have supervisors in AFBI and in LWIT as well. I research biomass here alongside Professor Ye Wang. He's like an expert in the field of biomass gasification and coal gasification. So I've been very lucky to work with him on this project, and Dr. Caterina Brandoni as well. She's another co-supervisor of mine, an expert in energy modelling. They've really helped me along this process. The novelty within my project is through the use of sustainable blends of materials, so matching a low quality biomass with a high quality biomass to improve the overall calorific value of the material, of the gas produced. So I've looked at unique blends of the material that no one else had done before, and found that it improved the heating value of the gas, and that in turn improved the efficiency of the conversion process in a CHP. So better electrical performance and heat coming out of the process. And I found that it's more environmentally friendly than current energy generation methods in Northern Ireland, such as grid electric or LPG, which would be found on these rural farms where it's most applicable for. So the focus of my research has been on agricultural waste materials, so poultry litter, anaerobic digestate, and tree trims, so brash it's called, and then some other materials I've looked at are miscanthus as a bioenergy crop, paper, and willow as well. The hard numbers from my research are blending the materials. The optimum blend had a 12.9% increase in energy content of the gas, so that's 12.9% more energy created from the process for conversion. So that means that a farmer could then use his own material to create heat and electricity on site instead of paying someone to take it away, and it is more environmentally friendly than current methods that he would be able to use. There's many applications for this process, so people who benefit from it are those based in rural areas who produce a biomass material as a byproduct from their process. So this can be anyone from poultry farmers, the wastewater treatment plants, industries like this that produce a waste that needs dealing with, but they might currently be paying for it. So they're going to have financial savings, and the process will be more environmentally sustainable. The next steps in my research would be to continue carrying out experiments on the system, improving the process. I've seen some parameters that I could make a bit better thermal insulation and better material handling. And then alongside that, I'm scaling up my experiments with our industrial partner, JMA, carrying out the experiments at full scale to make sure that the results are still valid. This unit here is for small scale testing, so if you applied it to an engine, I think it would be less than 200 kilowatts, but their system that they can run one at a couple of megawatts of energy coming out. So it's just, if this thing here is the size of a fridge, there one's the size of a house. Some of the practical issues with my research are the amount of tar, the byproduct that's created from the gasification process. It's like a sticky black substance, so there's a lot more research that can be done on how to minimize that tar being produced, and also to convert it into more gas, so more energy for you. We work with partners in AFBI who've been a great help to my project because they're experts in biomass themselves, and they've been able to supply a lot of the materials for me, either through different PhD projects or just material that they have on site already. They grow willow on site there. And then we have an external supervisor in Letterkenny as well, who's been a good help to me with the writing and the publishing side of my PhD. The biomass materials have all been supplied, either purchased or supplied through AFBI and other sources, and then I get them here, and the basis of it is weighing it out, so blending the materials together by weight and putting them into the gasifier and looking at the different blends. So I've been focused on like a blend of 80-20, 60-40 and 40-60 blends of them, and then converting them in the gasification process, and then seeing which one has the best energy content at the end, and then doing a full analysis then with the results. So I model the process, validate the model with the results from the experimental work, and then use the validated model then to carry out the economic assessment and the LCA, which is a life cycle assessment, to make sure the entire process is environmentally sustainable. So looking at the financial side of the project to see is it financially viable or not, because at the end of the day, a farmer or whoever is interested in this won't install it if it's going to cost them money. And then same with the life cycle assessment. There's no point carrying out this if it's going to be more harmful to the environment than the energy methods we're currently using. I'd like to work maybe in industry, being able to identify biomass materials and how to best convert them for energy use across the island of Ireland, because massive agricultural industry, so I think there's definitely potential for biomass to be more used than it currently is, or maybe even in a policy type job, promoting the use of bioenergy, because some people still think it's not renewable, where it definitely is.